Hello, this is Mr. Wilson. Hi, and we are getting ready to do some review videos. This is Kinematics, which you know is the study of math in motion. So numbers, we need to put numbers to our motion. There are 5 equations. How many equations? 5. 5. Okay. V average equals d over t. Acceleration is change of velocity over time. Vf equals Vi plus At. The Vf squared equation, Vi squared plus 2Ad. And d equals Vit plus 1/2 At squared. The order may be a little bit different, but those are the 5 equations. Now, what do you do in order to find which equation you use? You make your list of knowns and unknowns, find an equation, and there you go. This is how you do your physics. If you don't, you will fail. Your parents, they will wail. You'll never get a job, and you'll always be a slob. So make a list of knowns and unknowns, find an equation, and there you go. This is how you do your physics. Very good. So, these are the equations. For instance, if I were to drop a baby into its mother's loving arms. I don't know what's up with the baby's arms there, but into its mother's loving arms. And the initial velocity, if I were to drop it from rest, the initial velocity of the baby would be 0 meters per second, of course. And the acceleration of the baby would be 9.81, or we could approximate as 10 meters per second squared. And if I let the baby fall for a time of 2.2 seconds, then it will go a certain distance. So maybe that's what I'm looking for, is the distance. So what I do is I make my list. Initially falls from rest, it's free fall, and then it's accelerating due to gravity, time, and then distance. Now we know that 1 second falls 5 meters, 2 seconds 20 meters, 3 seconds 45. That is the displacement dive. So 1 is 5, 2 is 20, 2, like Zach Sikora wears on the weekend, and then 3, 4, 5, kind of like you're counting. 3 seconds is 45. So if I take this up here, I make my equation. Remember, ESU, equation substitution with units. That's my equation. And then I plug in, well, anything times 0 is 0, so this is going to be a 0 here, plus 1/2, 10 meters per second squared, 2.2 seconds. Now, I know that that distance is going to be somewhere between 20 and 45 meters. So what I'm going to do is grab my handy dandy calculator and do 0.5 for 1/2 times 10 times 2.2 squared, and I'm going to get 24.2 meters. So that's good, because that fits with my 2 seconds is 20, 3 is 45, somewhere in between there. Next thing, I'm going to talk about graphs for a minute. Okay, there are some graphs that you need to know that you will see on your table. D, T, and you've got your VT. Okay, so say for instance your baby is at rest. So we got the baby resting here. Okay? Well, the baby at rest would not cover any distance as time goes on, and they would also have no velocity, right? So that would be an example at rest. Now just think about that for a minute. We talked about how equations should be related to graphs, and if we went back to this equation right here, if you're at rest, I'm going to take this here and make it Vit again. If you're at rest and this is 0, then that means that this part, there's no acceleration. So you've really got 0 distance as time goes on. And so that's what this is going to be. And also, if you want to go back here, Vf equals Vi plus At. If you're at rest, you have, again, no acceleration. So this is 0 meters per second. And so you're going to have 0 velocity. So you're not moving at all. The baby's just chilling, cooing around, sucking its thumb. So how about this graph if I talk about now free fall for the baby? Well, now the baby's going to pick up distance. 1 second falls 5 meters, 2, 20, way up here, 3, 45, something like that. So it's going to be one of these jobs. And again, if you look back up here, d equals vit plus 1/2 at squared, now your acceleration is there. It's not 0 anymore, it's something, it's 10 meters per second squared. So you've got that square, which gives you the curve right here. But if you go back down to here, now even if you're accelerating, you don't have a square on the time. So it's going to be like this. And that ends our kinematics video. Thank you very much.